Well, I'm working on the switching concepts, and I'm trying to figure out a way to measure all of this toggling between puff and brake, go and brake, if you will. So I've set up a scope, and I can put it on channel 1, which is just one of the probes. And channel 1 right now is at 0. And if I toggle it, I have a switch right here, and it's wired into a 9-volt battery. So if I toggle it, a voltage will go. That means it's open, closed. Open, closed, open, closed. Okay? Now, I switch over to channel 2, and that's a different piece. That one is now normally closed. So right now you see some voltage going through. So this could be the brake. And then when I do this, it's now open. If I had it up at the same level, you wouldn't be able to see them, but trust me, this is now closed and it's now open. Okay, closed, open. Okay, closed, open, closed, open, 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 closed. Okay, now then I'll go to dual. So now I'm running them both. And when they pop, that means they flipped states, okay? See that? They flip states. When I trigger it, one goes high, one goes low. That means one is closing, one is opening. So that's exactly what we want to do. What I wanted to try to determine was the interval between pulses. That's what I'm trying to decide. As I run this thing up over time and try to get faster and faster, like if it was on a machine, you know, could I determine the delta or that pulse as it's coming? And I'm not sure I'm going to be able to do what I want or how I could even do it, but this is one thing I can do on the bench without all this other junk, and I can just sit here, and what I'm hoping I can do is inject this into the reed switches the same way and just watch their pulse as the magnet goes by, instead of me flipping this like I'm a cam, but I'm not a cam. A cam would be a lot more positive. I mean, that would be concrete. With the magnets, it's sort of like, where's the field? And each sensor has a different field. Here it's all in one. This limit switch could replace those, I'm thinking. So I could go there, I could go there, and that would seem to play into the pulsing that we need to do with the relay. So let me show you this. I'll go to position 1, which is, let's say this is the puff motor on, and it's off right now. It's on right now. Off, on, off, on. Now then, we'll go to the brake. The brake is on, off, 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 off. So when it goes off, the other one goes on. And it just seems like that should work for the motor and the brake. You put the brake on when the go is off, and it seems like that could replace the digital electronics if that is something we want to do. I don't know yet. Then we still need the relay and the sensors and stuff like that to see if that's reliable. I would have to grab one of these guys, like this one I think has it, and just see if that really works. And what I was trying to do was look at the intervals to see at what interval can this happen. You see here, you can't you can see almost, but you can't quite see the slope. You can only see it one way too. So anyway, that's what I'm thinking about. How to devise a very accurate mechanism that can be tuned off, and then when you plug this in, you know damn well what the fan's getting and what should come out the smoke, and if it's not, then you can take the fan apart. If it's too much, too little, increase or decrease the voltage, stuff like that. That's another thing I need to do, is tie this to a potentiometer and raise and lower the voltage with a constant fan heat, and determine how is that going to operate. With lower a lower volume of air, it should run a little hotter and have more smoke. But if it has a brake, low volume brake volume, then it should be a puff of smoke. Should be a better puff of smoke, is my opinion. But that's why I got to work out the switches now and the board. I'm going to build another board. I'm going to build another board just like that, only a little smaller. I think I got an idea how to make it smaller. And then I'm going to build another board without the digitals and just see, can I use a limit switch to perform the same stuff, and would it be reliable? Andy's concern was that it would bounce and you wouldn't get a good constant signal at the higher speeds. But there's a way to find out, right? Turn it on and find out. This is a Heath 4221. It's a 20 millisecond, 20 megahertz, 2-channel oscilloscope, and a friend of mine just didn't use it and didn't need it and gave it to me, and unbelievable. Mike Duncan, an old military school friend from a long time ago, we called him Dunk. He talked me out of buying a Harley Davidson and saving my money to buy a 409, which I didn't do. Well, I did buy a Harley later and damn near killed myself, so he was right. I shouldn't have. At any rate, another story, another day. I'm gone. Later.